All right, so let me reiterate. We're trying to integrate over this region D. I see that my y's are trapped between two constants, and my x's are trapped between two functions of y. The two functions of y, right? The two functions of y are this one, which is the line, that one. So if you go to the notes, this is the, oh, where is it? In my notes, this function of y on the right-hand side, that's what I call the h2 of y, and this one is the h1 is the one on the left. So this is h2 of y is equal to y plus 1. And then the parabola, right, which was that one, solve for x. Call that h1 of y. This one is 1/2 y squared minus 3. I know this looks messy, but I don't think about it in terms of like h2, h1. I think about it as in what functions on the right, what functions on the left. In like Cal 2, same thing, right? In Cal 2, we said, you know, like top function, bottom function. And then when you're looking at functions of y, you look at right and left instead. So I hope, can we set this up? Let me take a volunteer. Who wants to give me the setup of the integral here? Like write out what the integral would be. Anyone? I'll start you out. You got integral, integral. So what's the outer integral? Your constant, which are from where to where? -2 to 4. Okay. And now on the next one we have what? The two functions, starting with which one's on the bottom? The one that's on the left, right? h1. So it's going to be this one right here. 1/2 y squared minus 3. And then the top one, which is y plus 1, right, h2. And now what's the integrand? Shit, don't forget what the integrand is. xy. And then we're going dx, then dy. Why is it dx, dy? These are our restrictions on x, then these are our restrictions on y. Now I'll write out the d just in that form so we can see it. It's the set of all ordered pairs such that our y was stuck between -2 and 4, and our x was stuck between the 1/2 y squared minus 3 and y plus 1. So that's what D was. It's all the ordered pairs that satisfy these inequalities. You know what to do now? Antiderivative of this with respect to x, right? What is the antiderivative of that with respect to x? 1/2 y. So you're bringing y along for the ride? So you're doing just the antiderivative of x, which is 1/2 x squared, but then you tack the y onto it. So equals integral -2 to 4. Let's go ahead and get a bracket in here. The antiderivative here, you said, was 1/2. I heard yx squared. Is that all right with everyone? Yes. That's okay with everyone? Yeah? And then, careful here. Two functions. But what are we going to be replacing, the y or the x here? We're going to be replacing x because we're doing it with respect to x. So x is going to be replaced with 1/2 y squared minus 3. And then x is going to be replaced with y plus 1. Once we're done with that, we'll go and do the integral with respect to y. Now keep in mind while we're doing this, the reason why we have to really keep track of everything is because we are going to move on from this and get to triple integrals where we'll have x, y, and z. And so we're actually not going to have like this inner and outer integral. We're going to have like an inner and then a middle and then an outer. So we have to always keep track during the process like what variable we're replacing. Okay, so I'm going to stop here because I think we've done enough of these that you understand what to do now, right? Replace the x, subtract. You'll have a polynomial, put it together, you're back in Cal 2. So this is the picture of what it was. Okay. Everybody feel like they understand, kind of? All right. I'm going to give you 15 minutes to see what y'all can do. I don't want you, maybe 15 is too much. Let's go 10. I just want you to set up the double integral. I don't want you to actually crank the whole thing out. I want to see if in 10 minutes, you working with your classmates together, talking through it, if you can actually come up with a double integral that gives you this volume. All right? Try as much as possible to not use a computer, because I know some of you have laptops and stuff. Try not to use a computer to help you figure out what the region is. I think the hard part is the D on the ground, in like figuring out what type 1 or 2. And okay, 10 minutes, let's see. 11:43, I'll be back. So let me kind of talk through and you tell me whether or not y'all were thinking this or not, okay? You're trying to find the volume of the tetrahedron bounded by all, what, 1, 2, 3, 4 planes. These are 4 planes, right? Mm-hmm. Let's start with the easy ones, right? Z equals 0 is the ground, okay? And then you've got x equals 0, which is the YZ plane. So where are we here? Here's the ground. We've got the ground. We've got the YZ plane. Here's Y. This is Z. So we've got ground. We've got this. That's 2 planes. Okay, x equals 2y is a plane, all right? What does x equals 2y look like in 2-dimensional space? Just a line. So imagine we have a line here somewhere, right? And that's a plane. So now we got that plane. And then we've got a 4th plane, right? Now that plane contains all 3 variables, right? Not like this one. This one only contains x and y, which means it was a line that was vertical, right? A vertical plane like this. But that one should be a plane with some tilt to it, right? So you've got some plane with some tilt. You've got the ground, you've got this plane, and you've got some other plane. It's a freaking mess, right? So let's just look in 2-dimensional space. What do we have in 2-dimensional space? Let's draw these one at a time. Let's start with the easiest one. X equals 0. I can draw that in 2-dimensional space, right? Yep. X equals 0 is the y-axis. Okay. Now, x equals 2y. Let's do that. Let me label this. This is, yeah, that's x 0. For this one, let me write it this way. Heads up over there, Ethan. Did that go? Yeah. All right. Okay, so this one I'm going to write as y equals 1/2 x. So that's a line that goes through the origin and a slope of a half. So something like that. Now remember, these planes come up out of the page, right, at us? Okay. This z equals 0, right? Z equals 0 is actually this plane, isn't it? Yeah. And that's the ground. What about that one? Where does that hit the ground? Because remember, this is a plane that has a tilt to it, right? So somewhere it hits the ground, and when it hits the ground, it's a what? What shape? Well, I'm saying just that plane, where it intersects, it's just a line, right? What's the equation of that line? X plus 2y equals 2 because z is 0. See, that I think is one of the keys to this, is to figure out where this plane hits the ground, right? Means that you're going to take this, where is this in the xy plane, right? In the xy plane, where is it? Well, that, oh, it timed out. My computer timed out, sorry. That means z is 0, right, in the xy plane? So just replace z with 0, you get that. And now let's just solve this for y. Right? So that line represents where that plane hits the xy plane. So that means I go up 1, right? Up 1, and I have a slope of -1/2. So up 1, slope of -1/2 goes something like that. Yeah? Okay. Do you see D now? Yeah. Remember, I'm going to try and draw it. It's going to be really hard for me to draw this, but I'm going to try in 3-dimensional space. You try? How do I want to orient this? Let me do it this way. I'm going to make the x come out at us like this. Let me see if I can. I've got the y-axis, that's the red one, right? I've got the green one. The green one comes through here kind of like, oh, hard to see it. Comes through like this. Do y'all see that green one there? It's like, you have to imagine, like, if you were looking at it from up like that, looking down, it would look like this, right? And then you have the blue one, which hits the y-axis at 1 and then cuts with a negative slope through like this. Yeah? Yeah. And now, remember, that blue is where that plane comes through here, right? Comes through, and then you got this green comes straight up out of the ground, straight up. So we should get something that looks... I'm wondering if this is enough. Is this enough for me to draw it and y'all be happy? I don't know. Can you tell me where that plane hits the z-axis? Where does that plane hit the z-axis? Z-axis means x is what? And y is? So if x and y are both 0, what's z? 2? So up 2, that's a point on that plane, right? So we have something like this. Boom. Boom. That's your tetrahedron. If you'll see it. You'll see it? Now, there's that region that we just drew right here. There's that region. There's that plane. Okay, there's that plane. And I'll leave that plane in there just a little bit. You can see here. There was that region in two-dimensional space. Then we had our plane coming through like this. And so we want the volume below this plane down to that domain on the ground. Yeah? So what's your f? What's your f of x, y? What's your actual function you're coming down from? How do you get that here? Or maybe we should not do that yet. Maybe we should do this. Let's talk about the domain. Okay, draw that picture again real quick for you. Right? This was y equals, was it just 1/2 x, right? And this one was y equals negative 1/2 x plus 1, right? And then this one was x is 0. Okay, so tell me about that domain. It's the set of points x, y. Type 1, type 2? What do you think? This region right here. My x's are between two numbers, aren't they? And my y's are between two functions of x. What are my x's between? I think you can see from here it's between 0 and this one you might have to solve. How would you solve for that? You set these equal to each other, don't you? Let's set them equal real quick. So just add 1/2 x to both sides. Or sorry, subtract. Let's add 1/2 x. So over there you get 1. So x is 1. So x is 1. This is 1. So this region D is a type 1. It's type 1. My x is between 0 and 1. And my y is between, what's the bottom one? 1/2 x. Top one, negative 1/2 x plus 1. That's my domain. So this is type 1, right? Type 1. And so I know my integral is going to go from 0 to 1, and then 1/2 x to negative 1/2 x plus 1, and then some function, d what first? dy, because that's a restriction on my y, and then dx. But what is the actual surface? What's the actual surface we're looking down from? Isn't it the plane? It's that plane, isn't it? But to make it a function of x and y, you have to Solve for z, right? If I take this equation and solve it for z, I will have a function of x and y. So solving that for z, you would get 2, right? And then take these to the other side. 2 minus x minus 2y. There you go. There's your double integral. All right, does that all make sense now that I've run through it? Yes? Yeah, then you go through. I'm not going to go through this part, but the setup is the most important thing of these problems. All right, hopefully that exercise was